Firstly, if you're picking up the lo-fi I've currently got playing on my PlayStation, this will probably get taken down on strikes, but I mean I don't make any money from it anyway, so not a big fuss. I'm currently using an awful PlayStation microphone with like one ear connected to this side of the hood because I thought do that, or even if I do this, I don't know, it might be connection wise, I don't know. That's what I'll probably do. I'll just stick it on this bit of the hood, on my hat. That's a shout. If you're wondering why I'm wearing a hat and a hood, my hair is dreadful. So I'm trying to flatten it, and then I put this on to be warm, and I just thought I'd put the hood up. Great. I don't know if this is even going to work. It might work. That's not annoying in the slightest. But anyway, this is ALGEBRA. I've had many mental breakdowns recently about ALGEBRA, so I'm basically just going to go through the lectures I've already done. I'm trying to do a lot. I've got about 3.5 hours until my next 2 lectures. It's only like 12:40 and I start at, what, 4:15. I've got plenty of time. And yeah, it's just made me going through things that I didn't really understand, or re-going through them, and if anything I don't understand, I'm just gonna Google it. Like, I got my phone here. This is gonna be very unprofessional, but yeah, we'll see what happens. So I've done a little bit of lecture 1, and I got stuck on this bit. I know on the outset it makes sense, but I don't understand the wording of it. It says if A is a subset of B, when X is in A, implies X is in B. Because that arrow, the one-way arrow, normally means implies, but X is in A implies X is in B. But A is a subset of B. But if it was the other way, it'd be X is in A if and only if X is in B. Which doesn't make sense. So basically, I've Googled stuff on here and I'm trying to figure it out really. So definitions. There you go. What's this? When quantified is represented as for all X in A implies. Is that implies? It doesn't say. I don't know, it's kind of hard to find what the actual arrow means. And my lips are dry, so I'll be licking them a bit as well. There we go, brilliant.org. I think I did something with them. I can't really figure it out. I'm pretty sure it just means if A is subset of B, that happens when X is in A if X is in B. So when X is in A and X is in B, X is in A implies X is in B. That's saying there's a random integer, we'll say integer, random integer X in A implying, so kind of, well, implying that there's the same thing in B. Whereas you'd think that'd be the other way around, you know, you'd think if you're saying there's something in A implying that there's something in B, I think that B would be a subset, because that's basically saying, oh, something implying that this is in B. A is a subset of B when X is in A implies X is in B. Right. I'm pretty sure it's basically just all of A is in B. I don't think I really need to know the wording, but I want to have a look at the rest of the thing. And I'm basically just going to stick it on there. Oh. X is in A implies X is in B. Wording/meaning. There we go. Really professional. You can see my double chin right there. Meaning. one. I'm gonna keep checking this as well. It looks stupid as hell. That right here isn't even needed. I'm listening to nothing. The lo-fi is coming off on my PlayStation there. Anyway, no. A equals B when A subset B and B subset A. That makes sense. A is empty when A has no elements, i.e. X in A cannot. Again, that sort of makes sense. Right. Oh, bloody hell, right. If we down there, I'm gonna have to. Is this wire also connected to the laptop? You get a new view of my room. Look at that, you can see my think area. And my Spider-Man poster in the. Oh, I can't get the angle right there. Right. Oh, there is my Spider-Man poster. There's my work, wardrobe, me, curtain, sink, and then you got stuff to do a thing. And then right at the top of there, is a horse head. I'm getting distracted. 6 minutes. I don't know how long. It might even be 2 hours. I don't know. But I got some lo-fi background, which is always good. I don't even know if the mic even on. I'm just time wasting here. Oh, this is really hard to do. Close up. Oh, right. Yeah, it's on. It's definitely on. Let's try that again. Right. Yep, just push yourself in. Right. Ugh. So difficult. There you go. There we go. How's that? Do this. Hang it right there. Beautiful. Right. Well, after that. Right, let's look at the rest of the lecture. My double chin is so mad right now. Right. Don't question hat. I don't know if I mentioned that, but just don't question it. Right. If A is empty, this is something I got confused on last time. I didn't ask anyone about it. I should. I'm actually going to turn this down. Where is it? There we go. Get some chill while I find it. Right. If A is empty, A is a subset B. Okay. You can just kind of get used to that. The subset's always a subset. The empty set's always a subset of the set. The proof is what's confusing. Because proof says as X in A is never true, as it said on the previous page, that X can never be true. X in A can never be true if A is the empty set. There's nothing to be in the set to begin with. Then it says that X in A implying X is in B is always true. That's because if X is in B is also false. If X in B is also false, then it's a false, which is true. Because I think someone may have explained this to me. I think I may have asked him. It's like if X, it's like a truth table. So you have A, B, A and B, A, U, B. If something's false and false is true, something's double false and it's true, I'm pretty sure. And then here, X and this is scrap paper. I got some of these as well. If you need this pen, I got a blue pen. Right. So So I have trees getting chopped down just there. So I've got a lovely little what do you call it? Chainsaw just right through the window. It's beautiful. Right. So if X is in A implies X is in B, that's the same. I'm pretty sure we learned this analysis that it's A implies B is not A and B. Not A and B. It's analysis. I don't know if I can reach this because I'm being pulled. Oh, without looking, nailed it. It must be in it somewhere. I would have written it in. P implies Q is not P or Q. Right. So X in A implies B is not. So it's not X in A, or X is in B. So either X isn't in A, which is okay. There you go. So X in A implies X is B. If A is the empty set, X in A is false. But another way of saying X in A implies X is B is X isn't in A or X is in B. Therefore, if X isn't in B, you have a true statement and a false statement, which is true because it's an or. And then if it's true, and true, which is true. And there you go. Big brain time. Oh, you don't know quite how I'm tired right now. That's actually cheered me up. Damn. Oh, I put my Harry Potter. I'm forgetting words. I'm hyped. Slipper on. Yes. Right. If A and B. To be fair, I might get a new mic depending on if this one sounds good. I'm just gonna use this because it's free. But if this one doesn't sound good, I might genuinely just get like a £3 mic just so you can hear me. Right. If A and B are both empty, then A equals B because that's a subset rule. Yep. All of this, complex real, all of that. That's just something I'll need to learn about, which I might actually have to try and implement it now. I was trying to test myself on them. So, Z positive is positive integers. Cool, the answers. NO is the natural number starting at 0, which is 0, 1, 2, 3, 4, 5, etc. The integers are just whole numbers. Q is the rationals, which are, I'm pretty sure it's like finite numbers. For instance, 3 over 1 is 3, 3 over 2. No, 3 over 2. Yeah, 3 over 2 is 1.5. 2 over 3 is not rational because it's never ending. Same as like pi or root 2, they never end, so this is. Real numbers, that's just every number that exists, pretty much. Every number excluding i's. So pi, root 2, everything falls under real numbers, and then complex is x plus iy type thing, so then an I, so obviously you use them if you've got a negative. Yeah, and they're subsets of each other. That's lecture. So lecture 1, I can honestly say I'm good with. I've got to learn that one. X implies A, B thing. Just want to get the wording a bit right more than anything. I think that might help me understand it. Because even though I figured out the empty set thing, I still got to figure out. I still got to figure out like what the actual empty set thing is. Let me just stick this. I was gonna have to let it. We can let it dangle. Right. For any set A, I could probably open the window. I don't make eye contact with the random. But if I look out now, yep, there's a tree man searching person, like woodcutter, literally right there, and I'm on like the third, fourth floor, just directly out my window. So I'm just gonna leave that please. Oh, I said give me a headache though. Right. For any set A, the power set and the power set is built of the subsets of A. You know, and all the subset of, so if A is 1, 2, the subsets of A are the set of 1, set of 2, the empty set, and the set of 1, 2. Which is what it says here. There you go. I know that. Cardinality, not mod. It's basically just how many elements it has. Straight up, you know? So if A is 1, 2, 3, its cardinality is 3 because it's 3 elements. And then the power set, that's 2 to the power of mod of the cardinality of the set. So if A is 1, 2, 3, the power set is 2 to the cardinality of A, which is 3, which is then 2 to 3, which is 8. And you can also look that in your head because you have power set of it would be empty set 1, 2, 3, 1, 2, 1, 3, 3, 2, 1, 2, 3, which is 8. So it makes sense, but I think it's just a much quicker. If you've got like A is a capital I, which is 1 to the n, you don't want to be figuring that out. Although that just equals 2 to the power n. And then the power set of the empty, well, the power set of the empty set, well, the empty set is a subset of itself, so it has 1. So then the power set of the empty set, the cardinality of the empty set is 1. So the cardinality of the power set of the empty set is 2. Nope, I'm wrong. 1. Cardinality of the empty set itself is 0 because there's nothing in it. The power set of the empty set includes only the empty set. So the cardinality of the power set is 2 to the 0, which is cardinality of it. So it makes sense. And you got pairs, triples, and tuples, and nothing. The pair 1, 2 doesn't equal 2, 1, because if you look at it on a graph, the point 1, 2 isn't the same as the point 2, 1. Same with triples. The point 1, 1, 2 would be on the x, y, z plane. That's not the same as 1, 2 because you've just ignored an entire, an entire axis. Right. Now Cartesian, we don't understand the meaning fully, so I'll put it on the list. Like, it's just one of those words that you keep getting told. And you never learn well, most people don't know the name of it, but I never learned the name of it, so I can't actually, it's just kind of something that I know is a math thing, and I know it's relatively easy, and I'm pretty sure they'll just have to say, like, it basically just means cheese or whatever, and then it'll be like that, you know? Right. So Cartesian products, A cross B equals the set of AB, so A's and A and B's and B. I would have thought, see, that confused me as well. Actually, what I might do right now is actually try and find the meaning of the word Cartesian. Well, I've got messages, so I'm probably just going to check them as well. Let's see. Oh, my lips are dry as hell, so I've been licking them. Right, so he's had scrambled egg and beans. That's always lovely. Whilst my phone slowly crashes from having to turn on. Right, on Chrome. What do I want? Cartesian mathematics meaning. Anything that derives from Descartes' conception. Is based on the representation of points in the plane. Right. So I know it comes from Descartes. I'm just going to literally pronounce it how it's spelled. That is so annoying. I don't even know if you can hear it. You must be able to. It's so loud. But yeah, I think it just means like points, like the Cartesian. I think Cartesian is just x, y. Oh, whoops. That's not good. I keep getting it caught on my thing. Right. Oh, this is just fantastic. You're slowly moving further and further to the left. It's just, luckily, that little glance I just had, they've cut. Look, it's not good. I mean, I donated 5 trees to the team tree thing, but they are gonna replant the trees. I'm gonna put that out there. But right now they've cut a lot of it down, which for this moment itself is good because it won't distract me, even though it's distracting me right now. But it's bad overall because obviously cutting down trees is never a good idea. But they are going to plant some more, and yeah, hashtag team trees. Right, got an itchy back. So Cartesian, I'm pretty sure is just like the xy or the point A B type of thing. But then product is multiplication. So A times B is equal to the set of A and B, where little a and little b, where little a is in A and little b is in B. But like, where does the multiplication come into that? No, so I understand Cartesian. So, right, let me add this to the list. Because I want to make sure I fully understand the previous lecture, you know, before I move on to the next one. Because then if I understand it all, you know, the next one I should be able to, it should hopefully just be building on stuff I already know. Oh, yeah, literally, hopefully. I just said literally, hopefully. I'm gonna have to have a shower later because the reason I got this hair, my hair's a mess. So I'm gonna have to wash it. I don't know, I'll do something. Right. Cartesian powers. But then, okay, right. What? Cartesian, I'm pretty sure was a point A, B, or X, Y. But then, it just says Cartesian powers. What was the title of the last one? Professional as hell, right? Product, so Cartesian powers, capital A squared is A times A, which would equal. Ooh, would you write A1, A2? Would you write the set of A1, A2 such that A1 is in capital A? A is the same. So surely you'd write. No, you would. I was right. We'd do it further on. It's capital AN equals a set of A1 AN such as AI is in A. So they're all in A. I'd have to do I. Okay, that makes sense. My phone's close. Yep, Instagram message. My close to the phone, my hair. I'm responding well to it. That's currently what I've got my hat on. Right, let's watch this. Yep, scrambled egg, beans, rocket. That's just. He's very proud of his meal. Right. Cartesian. Oh, I don't know what Cartesian means. Alright. Oh, I'm gonna have to uncross. I'm gonna put it in there. I have a feeling it actually just means like a point on something. But I'd rather like know for sure. And for finite sets, the cardinality of A cross B is just A times B. Cardinality of A1 is the same thing. And cardinality of A to the power of n equals cardinality of A to the power of n. There you go. And r squared we all know is plane xy. Descartes. Oh. We can multiply. Yeah, so here says Descartes, and he's bloody Cartesian, so I think it must be xy. Something along those lines. Right. Circle with radius r. Well, yeah, x and y. Such that x and y are in the r squared, which is basically the xy plane. So x plus y squared equals r squared. And the positive quadrant, x plus y squared is greater than 1. Oh, x is greater than 0, y is greater than 0. Right, positive quadrant, x is greater than y is greater. Well, that makes sense. I was just being dumb. Right. Subsets can be described by specifying a property that characterizes these two elements. X is divisible by 2, you'd say x equals 2y, where 2y is an integer. Makes sense. I drink. Oh, I eat. I haven't eaten. It's 1 p.m. I had lecture at 9 a.m. Woke up at 9 a.m. I had 15 minutes to get there, and not gonna lie, I made it. Not gonna lie. Alright. Given sets AB, A union B, where's he up to? Oh, there's another tree. It's like, oh. This is just gonna come. The window's closed. Like, it's so closed. I could go to the library, but I won't be able to do this. I think this is gonna help me. Right. Positive quadrant, x greater than a, x greater than 0, and y greater than equal to 0. Now, to describe x equals 2y, yep, and you also have to define whatever you use. So a, whatever letter you use, you need to define where it is, where's it from. So you couldn't say, for instance, x is in the integers such that x is green, because that does not make sense. How does x being in the integers affect anything to do with x being green? And it says here x such that x is divisible by 2. You haven't defined what x is, so that wouldn't make sense either. Right. Given sets A and B, we have union, intersection, and difference. That's fine. Given an itchy thigh. Given an index collection of sets, AI such that alright. Bloody hell. We have capital I, which is the indexing one. We all know that. So the big union of little I and big I, so that's basically I goes from, that's the same as writing I equals 1 and then n at the top. AI is basically the same as saying a set of x such that x is in AI, some I in I. And then this intersection, it's for all. So union is this, or this, or this. So it's for some, because it's not all of them. Does that make sense? Because union is kind of like, oh, you could have 1 or 2 or 3. Whereas, so it's like some you could have 1 or 2 or 2 or 3, you know? Whereas intersections, 1 and 2 and 3. So they're all in that one, rather the other one is kind of, you can have this or that, or you can have both. Alright. So intersection and difference are both subsets of A. The intersection between A and B, a little bit of A, is Venn diagram time. The difference is they're at the other bit of A. So if you add the intersection of the difference, you get an entirety of A. Just a fun little trivia fact for you there. Alright, when B is subset of A, A take away B is a complement of B. It makes sense because A take away B is get rid of everything with B in it, and that's, which means that there's no B in A, which is the complement of B, because the complement of B is It's everything that isn't B, which would be A. Right. X is in the union if and only if X is in A. It's the same thing. Right, commutative means that brackets don't matter. No. Commutative means order doesn't matter. And then placement of brackets is associative. So intersection is commutative because you can do A and B or B and A. It's still the intersection between A and B. And then brackets, if you have A union B or bracketed union C, that's the same as it's the union between A and B union C, because that just means A or B or C, and no matter where you put brackets, it's still going to be A or B or C. And funny enough, union is also commutative because A or B or C is the same as B or C or A. Whereas A and B intersection isn't associative because A and B and C, if you have A and B in brackets, that's just the intersection between A and B, and then you want to intersect that with C. That's not the same as the intersection between B and C, and you want to intersect that with A. Or is it? Hold up. Let's do some working. Drop that directly on the floor. Fantastic. Alright. Draw a cheeky Venn diagram. So you have A, you have B, you have C. A, B, C. So the intersection between A and B, or that, and you intersect that with C. Look at that. No, never mind. Both intersection and union are associative and commutative. There you go. An associative place in brackets, commutative. What do you call it? Commutative is the order in which they're doing it. Alright, we've done lecture 2. Hip hip, hooray! Oh, drink. Something to drink over there. I don't know what bottle it is. I think I have one. I'm not drinking that. That's probably stale as hell. Right. That's going to give me a headache. I might have some paracetamol, you know. But first, let me do some maths. So X is in A union B union C is the same as saying X is in A union C. We did that last one, you should know what it means. I can't even hear my lo-fi right now. It's associative, it's also commutative. Well, apparently union isn't commutative, so order does matter. That doesn't make sense. Why is OR not commutative? Because commutative is the order. And you'd think if you could pick between 1, 2 or 3, that's the only thing between 3, 2 or 1. You can have 1, or you can have 2, or you can have 3. Or you can have 3, or you can have 2, or you can have 1. It's the same thing. I think that should be commutative. I'll put on the list. Is union commutative? We've got 4 things. Which isn't bad. I mean, that's going to be something. After I've done lecture 3, I'm going to try and Google one of these. I'll probably just cut this video and then after I've gone through it all, and then just do the other one, have like 5-10 minutes, and then do another one. But I'd say once I hit, in about 2 hours, I'm gonna have a shower. and then that'll give me what, 40 minutes to then have a shower, get ready, chill. I'm good with that. Right, algebra. I've also got a problem sheet due in two and a half hours, and I can't even do it. Like, you keep saying how easy it is. It's not. So I might do actually is finish this lecture here, get all the answers to these questions, and then try and get that problem sheet done, and then I might be able to hand it in before I get to my lecture. I don't know. Who knows? I might try to do that on here as well. That'd be fun. You'll basically just see me doing this for most of it. Could be fun, you know, revision thing. Who knows? Oh, I got another security thing. Yep, you've gone now. Great. Alright. Right, I understand that. A takeaway B and the same B takeaway A. I mean, this thing, I'm still getting stuck on the A takeaway B takeaway C thing. Right, so we have A, B, C, A, B, C. Alright. So if you A takeaway B, so this is A, B, C, A, B, C. If you make that A takeaway B, leaves you with all of this. Well, yes, and see, you have three separate things. A takeaway B, does that involve the C? Or is that just A takeaway B, so you only have that A, and then when you take away C, I think it's A takeaway B. We're just going to assume that just B isn't in it really, so then you have all of them, taking away C, you only have that bit left, okay? And then B takeaway C, we have none of that, and then it's A takeaway left. A takeaway, B takeaway C. So B takeaway C, you're literally left with B takeaway. Yeah, you're literally left with them. Literally left with that little bit there. And if you take away, and then if you have A taking away what's left, that's add to the list. A takeaway B takeaway C does not equal A takeaway B takeaway C. I'm going to be able to picture it. Like, I don't know if I'm interpreting it wrong or something. I can't quite wrap my head around A takeaway B takeaway C. Is the A takeaway B, do you include the C in what the outcome of that would be, and then take away C from that, or is it A takeaway B and then you're taking away C but you don't include C? D. How? I think it might be actually A takeaway B. We'll assume that you don't include the C in that. A takeaway B, straight up, you have all that. And takeaway C, you have the little intersection between the two. B takeaway C, you have the intersection of B. A then taking away that intersection. A then takes away what was left of B takeaway C, which equals the same thing. I don't understand. Alright, union B don't the cardinality of A union B doesn't equal A plus B. Unless they are disjoint, otherwise they equal A plus B take away the intersection. Right. Given sets A and B, the function. Oh, functions. I hate functions so much. Given sets A, B, function f of A to B, A implies B is a rule which assigns every element in A a unique element in B, and the element in A is x, and the element in B is f of x. Because the function is moving But if you have if f of x equals x squared plus 2x plus 3, then you have an x, you have an f of x, and you have the actual function. I'm pretty sure this is basically a fancy way of writing, right? Like you have f of x is the outcome. And if you have x squared plus 3x plus 2, if you sub in one of these random x's in A, an f of x is going to pop out in B. And I think that's what it's trying to say. It's like, oh, you can sub in any x here, and if you sub it into the function f of x, which is the function, that's then going to be a unique point in B, because x is in A. X is just a random thing, and we're going to say it's in this random thing A. You sub this into the function, so you sub that into x squared plus 3x plus 2, and the unique f of x is going to come out, and that's not in A because it's gone through a function, so we're going to say it's in B. Boom! In the words of Jack Films, fix your pick, sure of mathematical induction. And though that was an induction. A is the domain of f and B is the codomain of f. So you kind of have to learn the codomain is the bit at the start, domain bit at the end. Not much really you can do with that. Ooh, I think we did do a bit of induction, you know? I uploaded 2 videos, I'm not gonna lie. By the way, I'm just going to do this, I'm going to try and find the answers to these. I'll do a problem sheet, and then I don't know what I'll do. I keep looking at myself in the camera, and I haven't been looking at you much. I sincerely apologise. Right. If I had a bigger camera, or I didn't have my face there, like if I had like most people have like 1, 2, and 3 screens, and they'll have that there, but the camera will be there, and then all these stuff here. So then when they have to look somewhere, they won't just look at the thing they're looking at. They'll look at the camera above it, and they won't be able to see the stuff. Whereas I'm just looking at. Basically, it's basically I'm talking to someone, and as I'm talking to you, it just happens. They're looking at me, and it's always impolite when talking to someone to look them in the eye. So I think that's what I'm doing. I should try to look at you, and I mean it's pretty easy. I mean I can do it right now. But so when you do a glance, you just. And when you're talking to someone, you'll be doing work, and you just have a glance and you look in the eye, and that's what I would do. And I realise it's me, but then I have to commit to it because I can't just do it like this. That. It's a bit odd. So it's either I commit to you, or I commit to myself, and it's one or the other, really. But anyway, moving on from me basically using excuses for wanting to look at myself. If you have 2 functions, f of g, both go from a to b, then you can say f equals g and f of x equals g of x, because they both have the exact same function. If you have 2 different domains, my mum just wants some Christmas gift ideas. Ooh. Well, I need to get my family Christmas gifts, but because I live next to some very good Christmas markets, I can easily find some things. Right. 2 functions with different domains or codomains aren't equal, full stop. Because if you're going A to B and then A to C, well, that means the entire function is different. So if A, x, b, f of x, and then you have the function f is the function x squared plus 3x plus 2, that's not the same as x squared plus 3x plus 1, a different thing, therefore, different. Oh, but that can be the same though, even if you have the same function. So you can have f being x squared, because, alright, if you sub in a rational number, which is q, rationals are just, you have like a to b or something. I forget the name when I get here, but I remembered it earlier. Because you can then, if you have x to mapping, if you go from x to x squared, if you have x and you, so say x is 3 over 2, squaring that's 9 over 4, which is, what's that? That's 2 1/4. You know? And you can also do an integer to a rational number. That's just anything, because an integer is a whole number, so 3 squared is 9, which is 9 over 1. But 9 over 1 is also 9. So basically any two functions with a different codomain or domain, so if they have if they have the same codomain but different domain, they're not the same. It's just kind of a rule of thumb. If it's not identical, it is not the same. And they could have the same function, but they're not the same, because a rational number isn't the same as an integer. You can have integers in rationals, but you can't not all integers are in rationals, not all integers are a subset of the rationals. Rationals are not a subset of the integers, therefore they're not equal. Boom. Fixed your maths. Given a function from A to B, the graph of f is a subset of A cross B. Well, I don't understand what A cross B is. I think it's more than likely A cross B is just A times B. That's my opinion. But we've been doing multiplication recently, and he's done a dot, which is kind of like the more professional way of doing it. So I'm not quite sure if A cross B means something else, or it literally just means A times B, and it was easier than doing A dot B. Change its mind, you know? People change their mind. But the graph of f is a set of AB such that it's in A cross B, such that B is in equals f of A. And again, that's what makes sense, because if you have, say, if you have, say, y equals x squared plus 2x plus 3, I'm going to keep using that one. I'm going to do 3x plus 2 last one, actually. You can then let y equal f of x, and then sub in things until you can get a value of y where f of x equals 0. I'm pretty sure this is what this is. The graph is just, you're trying to get a specific value for f of x equal, and then that whatever value the f of x is y, and then x is just, well, whatever you had to sub in to get the value. Function A to B, the graph of f is a subset of A cross B. Alright. I've got... You're not run out. What? What's happened? Look. There you go. I thought I had staples in this, but it wasn't working, so I've been using my mini one. But clearly, oh, these are really there you go. Good as new. Alright, so given the function f from A plus B, the graph of f is a subset. And the graph, I'm pretty sure, it's just a random point. So every function, so y equals x squared plus 3x plus 2, or 2x plus 3, I don't know which one I'm using, I'm going to vary from 2. That's always, you can always plot that on a graph. Always. And so, for instance, I'm just going to do a mini, I'm only going to do like the first 2. So if you have the y value, actually, I'll show you this after I've drawn it. X squared plus 2x plus 3, with x is 1, y is, what's that, 3 add 2 add 1, 3 add 6. That's about what there. If x is 0, y is 3. If x is minus 1, that's 1 take away 2, which is minus 1, and through to 2. If it's minus 2, that's 4. Take away 4 and 3, which is 3. And we'll just do another 2 here. That's 4 add 4, which is 8, 9, 10, 11, which is here. So you can see, right, just incredibly briefly, I've plotted it there. Yeah, negative 1 is here. It might be reverse flipped for you, I can't remember. That's pretty much what it looks like. And yeah, so you can always plot a function, and I'm pretty sure this is just plotting a function. But instead of, like, you have an A and a B, and then f of B, if we're saying here that B is y, A is x, so f of x equals y. That's the gist of the graphing. I really don't like the fact they use A and B. It makes sense because you've got a function from A to B, but x and y, it's easy. If you talk about a graph, just do x and y. Don't be stupid. So if we're gonna let G equal the graph, so I can't be asked to write graph each time. So it says here that G is a subset of A cross B. Don't really know what A cross B means, but we're gonna assume that we know what it means. For some function of A to B. So if G is a subset of A cross B, then for each little a in A, we're going to say x in this case. For each x in A, there's a unique y in B, such that the point xy is on the graph. Wow. This is basically saying all the points. This is basically saying you have, yeah, points. If you have a function, there's many points. Each point is a subset of that because, well, great. For sets A and B, they're just random sets, you write b to the power of A it equals the set of function. That's a weird thing to write. For sets, two random sets A and B, you'd write b to the power of A equals the set of functions f from A to B. Functions. Where's this s come from? B to the power of A is a subset of the power set of A equals B. Okay. Alright, this one is B to the power of A. Either. B to the power of A sets. If A and B are finite, then the cardinality of B to the power of A is the cardinality of B to the power of A. That makes sense? Because the cardinality of n is just n, that's why I didn't. Basically, if you have the cardinality of something to the power of something, if the something is a known number, so n, that's the size. So the size ain't going to change for it, unless it's negative, in which case you basically make it positive. That makes it normal, that's GCSE. But if it's an unknown, so if it's like a set A or if it's an x, then just leave it in cardinality form. Basically, if you have anything to the power, so x to the power n inside cardinality, that's the same as writing the cardinality of the base to the cardinality of the power. And with numbers, you can normally just get rid of the cardinality on it, but that's a much easier way of thinking about it. Right. So here, and if B has two elements, that's the cardinality of the power set of A. It's just a fun little thing. Right. If you have the function going from A to the set 0, 1, then you say what? than likely gonna have to just watch the FXA0. What I'm probably gonna do is watch the lectures on my phone, and then I'll just kind of see if he explains it better, and if not, I'll do some googling. But I don't understand line slides. I also need to go to the loo, so I'm probably gonna pause this, come back. Right after I get to the end of it. So X is in the set of A and A such that okay. If F goes from A to B and G goes from B to C, then you got the composite which is A to C. Oh, I need to poo so bad. Alright, I'm gonna go, I'll be back. This will move, everything will move, but yeah, I'm just gonna pause it, I'll be back. I think I just missed the pause button there, so you would have had a quick just before I got here. Anyway, that was fun. They're still cutting down stuff. Right, so I'm like 3 paragraphs away from finishing this lecture. So let's do it. When the function A to B and G to G, the function G from B to C are functions. Great. Then their composite GOF. Right, we did that. It goes from A to C, given by GOFA with GF of A. And that's, again, pretty much, if you look in terms of the x and y functions again, if you have f of x equals x squared plus 3x plus 2, right? And then g of x equals root x. Okay, that's basic, I know, but f of x, the x you sub in that is going to be in A, and the output of that is going to be in B. Okay? Whereas the input in g of x is going to be B, and the output is going to be C. So when you do g f of x, well, that's the same as the square root of x squared plus 3x plus 2. So then the input in that one is A, because the x is in A. The output then of that, the output of the x in A bit is the x in B. So the x over 3x plus 2, that's going to go from the x bit, and that is the A. The x over 3x plus 2, the result of that bit alone will then be the B. And then that B is then all going to be square rooted, which will then send it to C. So pretty much you have a function that goes from A to B, and you put that into one that goes from B to C. Well, the output of the one that goes from A to B is B. And then you'll then put in that B into the one that goes from B to C, and therefore you can basically skip the B bit and just go straight from A to C. Boom! Oh, so good. Right. You only use composite when the codomain domain are equal. Makes sense? Because if g of x can only take, B to C, if the only thing going in that is B, if you've then got A to D per se, well, that D it's not in the input of B, unless you've specified that, no, not even that. Basically, in order for this f of x, like normally f g of x normally is always just going to have the same thing. It's A to A normally, or A to B. It's normally what they both are, or A to C, B to C. Whereas this, if you have A to D, so if you have x squared plus 3x plus 2, okay, and the result of that is D, you can't sub in g of x because g of x can only take in b's, and D is in B, therefore you can't sub it in. Boom. Alright, composite is associative, which means brackets don't matter. Because if you have H from C to D, then the composite of H composite G composite F well, GOF is GF of x. Okay. And then h of that is hg of x. And then if you have h of g, well, that's h of g of x. You're then compensating the f into that, which is then hg of x. Okay. There you go. That's h of 3. So we're doing good. Doing good. About half the way there. I've got 2 hours, so it's just 6, then I'll have another big break after that. So I'll probably go like 2 or 3 more and do the same sort of thing. In here, and then I'll be up to 6, and I'm up to about, I try to do the math earlier actually, 7, so what's that, 4 times 3 is 12, add 3 times 2 is 6, so 18, at the end of this week I should have had 18 algebra lectures. Done tonight I'll have done 6, so that's a third in one day. It's going to get harder the more we go, because I won't understand any of it. But if I can get 6 done in one day, that's pretty good going. And also tonight want to set up a, let me add it to my to-do list actually. Microphone, I'm going to listen to this first, and if not I'll get a microphone. Microphone, I need to get that thing, and then, what's it, I was just on about it. I was literally, oh yeah, and then plan which days I'm going to do which topic. Oh, and I also have to do, yeah, I also have to do that. Because, what I want to do, because we have 5 courses, so what I'm hoping to do is, I've got about 6, one night a week I've got society. So I'm kind of scratching that night off. That night's my day off. It varies normally a Tuesday, but it can vary to, you know, Tuesdays, Saturdays. But it can be any day really. And basically, what I've got on here is I want to. If we have five subjects, I need to revise all of them. So my plan is, say, do algebra on a Tuesday in this 5-hour gap I have in the middle of the day. Analysis on a Monday, you know, so it goes like analysis, algebra. I can either do it in I can do algebra in the 5-hour gap, and then I can still have the night off. And then Wednesdays will mainly be doing any homework I've got left. Actually tonight, probably after this, I've got some homework to do, which will be another video. Homework, and then I can do methods. I got discrete, all of that. I'll plan it all tonight. I'm on my laptop right now because I can't be asked to on my phone, so you'll see a lot of me. Even though you normally see me staring straight at my screen, that's especially what you're going to see now. And I'm pretty much just going to search things I got stuck on and find answers, which is all of these. So number 1, I can't do here. I'll have to do somewhere else. I'll mention it in my 3rd video today, probably. Cartesian meaning. Let's see if I can actually figure it out. Yep, already searched it. Cartesian meaning in math, in the American. Cartesian plane is the XY plane. Right. I don't want a Cartesian plane, I want Cartesian. But here I think, here it's just saying Cartesian product. That's what I was stuck on. Well, here we go. Cartesian product, x times y between 2 sets x and y is a set of all possible pairs. Oh, so x cross y is just x. Well, that sorts out the x a cross b one as well. Right, so it's Cartesian coordinate. So x a cross b is every pair of every ordered pair AB. Right. Well then, I've got Cartesian is it is points, and A cross B is just the set of all possible ordered pairs. It's just pairs. It's literally what it is. You have the pair AB. Yeah, I just couldn't figure out in my head. Right. Right. The next one is union commutative. Union is commutative. Yeah. There you go. Great. Thought it was. Right. Oh, this one's going to be difficult to write. Oh, because. Right, no, we're just going to stick it out. Right. A cross B cross C is not equal to A cross B cross C. The fact that you need to be one of them. Here we go, I think I found it. A minus B minus C subset of what's it called? Difference sets. Difference. Here we go. Complement and set difference. It's just called set difference. Right. Great. I want to see the fact. Right. Set difference. Was it brackets is associative, right? Yeah. Set difference is not associative, and here we go. So R take away S is equal to R and not S. That makes sense? Alright, so you can represent R take away S equal to T is R, the intersection between R and S and not T. It's equal to R and not S and not T. Right? Second, that's R and take away S take 3, but then ooh, yeah, makes sense. Bloody hell. Right. Let's get a big one. This must be thrilling for you, literally just watching me react. I'm still better than most reactions. You can't even see what I'm reacting to, and I'm still better than at least 50% of them. Right, so what was the way I wrote it on here with ABC, right? So A take away B take away C is equal to A and not B, so we're doing complement for this. A and not B and not C. Because if you're taking away is the same as saying it's you're with not that. Okay. Alright. And then what's the other one? A, right. So then underline, well actually we'll put a square around that. A take away B take away C is equal to A and the B and C complement all complemented, which is equal to A and B complement and C, which makes sense. Oh wait, what? Oh, because when you complement an entire thing, it becomes. Oh, when you complement an entire thing, yeah, it becomes an all. There you go. That's just not the same thing, then, is it? R and not S. Oh, wait, no. Wait, which is then, yeah, which then equal to A and BC, or A and C. There you go. It's an awful proof, the way I've done it. But I'll jump to go a second so you can see it. But basically, the question was the fact that those two things are unequal. And the reason behind it is A take away B is the same as, so if you have a Venn diagram, let me get it ready. Right. So that's A, that's B. So A take away B is basically all of A take away all of B, so you're only left with this bit, not including the intersection because the intersection is still in B. Right. That's the same saying you have A and you don't have B. Because A and not B is just that bit there because that bit's in B. That's the same thing. So you can then say this as saying you have A and not B, and then it's not C because that's also been taken away. Okay? The other one then, A take away B take away C, is A take away that, so that all of that is complemented, so that's A take away, then you can complement that while you're at it, which is B and C complemented. When you complement an and, the opposite of an and is an or, and then yeah, I just sorted out the complement on the B and C, so it became A and B complement or C, which then becomes A and B complement or A and C, which is different to that, because that's saying that and that and that, that and that and that, that's that and that, or that and that, which is different. Boom. Proved. B to the power of A. God, this is going quite well, isn't it? Sets. Where have you got complement from? Oh, I can't remember what it was. Lecture 2? Was it? B to the power A? A bit lecture 3. This one. This one. Sets A, B, we write B to the power set of A. No, B to power A. And B is a subset of the power set of the A cross B, which is the set of pairs. What? B to what? I don't understand this. That one I'm gonna have to ask because that was confusing as hell. Right. And then fx, and I'm gonna have to ask about that one. Okay, that's pretty good. So I've only got 3 that I don't know. So I'll ask about them and I'll mention them probably later tonight. Yeah, that's it for this one. I'm going to do another one in about 5-10 minutes when I do a problem sheet, because I'll be handing that in about, well, I've only got an hour left. I'll be handing that in an hour.